So the next important parameterization that we learn is the parameterization of a circle. So the thing you should know is that a circle with center 0, 0 and the radius r has the parameterization r cosine t, r sine t. And just to change it slightly, to the circle with center AB and radius r. That circle has the parameterization a plus r cosine t, comma b plus r sine t. In a sense, what you can do is you can think of it as though I'm taking a circle with center 0, 0, like that, and I'm simply moving it to some arbitrary point AB. That makes sense because what I'm doing here is I'm simply adding the point AB to the parameterization of the circle. You can think of this expression here as simply a comma b plus r cosine t, r sine t, using that sort of arithmetic of points that I gave you earlier. Essentially, this is what you're doing is you're just translating the circle to a different point, AB, in the plane. A couple of things to note here. So first of all, you already know one parameterization of one circle. You know about the unit circle. The unit circle is, this is the unit circle, and we know that every point on the unit circle is cosine theta, comma, sine theta. So that's a radius of 1, and instead of using t, we're using the letter theta, but of course math doesn't care whether we do this in the Roman alphabet or the Greek alphabet. It makes no difference. So this is essentially a parameterization that you already know. The other thing to note is that this parameterization, including the one you know about for the unit circle, is generally understood to be valid for negative infinity less than t less than infinity. In other words, even though you think of the unit circle as really being traced from 0 radians up to 2 pi radians, if I keep going, or for that matter, if I add in negative radians, I just keep tracing the same circle over and over again. And this is an important point about parameterizations. We don't require that every point be generated only once. It's possible that different values of t generate the same point over and over and over again. So if I keep letting t just keep going out to infinity, what I get is I just start tracing the circle. I just keep going around and around and around and around and around and around and around the same circle, with generating the same points many times, which is fine. Parameterizations just work that way. So let's see. Okay, so that's another thing. The third thing to note is that this is not the only way to parameterize the circle. It's just kind of the standard way to parameterize the circle. If someone says, give a parameterization of a circle, you would certainly be reasonable to give this one. But I just want to be clear, it's not the only one. It's specifically the parameterization that starts at this point here and then traces the point going counterclockwise in that it traces the circle from the point 1, 0 going counterclockwise in that direction. So there are other parameterizations of a circle. So here's an example of a problem we can solve knowing the parameterization of a circle. We're given the equation in Cartesian coordinates x minus 3 squared plus y minus 2 squared equals 9 fourths, and we're asked to give a parameterization of the circles, right? This is a parameterized curve. So recall that we can parameterize any circle using a plus r cosine t, comma b plus r sine t, where r is the radius of the circle and a comma b is the center of the circle. So we can read right off of here that this circle has center 3 comma 2. That's just a fact we know from our earlier pre-calc courses, the analytic geometry unit of those courses, as well as the beginning of Calc 1. We teach this point also. And we know that the equation of a circle is x minus a squared plus y minus b squared equals r squared for a circle of radius r and center AB. So we can see that this is equal to r squared. So if 9 fourths is r squared, then that means the radius must be the square root of that, or 3 halves. So the radius is equal to 3 halves. That's fairly convenient. We have a center of 3, 2 and a radius of 3 over 2. So that gives us the parameterization 3 plus 3 halves cosine t, comma 2 plus 3 halves sine t.